So in this video, I'm just going to work through the core practice sheet odd numbered problems in case you're looking for some guidance. This is going to go pretty quick, so feel free to pause and rewind as you need. So in the first, I noticed, okay, nothing to really move around or combine. It's all just about taking care of this negative exponent. So I'm going to leave the 4x squared on the top of the fraction and make it y to the third, on the bottom. I know I'm finished because there's no negative exponents, nothing more to combine. Here, number 3, very similar. I've got an 8x to the fourth. It stays where it is, but because of that negative exponent on the y, that y is going to move downstairs, become a positive exponent of 2. Next up, very similar again. So the 3 stays where it is. The a squared stays where it is because the exponent's positive. The negative exponent's going to move downstairs, become a positive exponent. Next up, take it a piece at a time. So the 2 times the 6, that's 12. Now the a's, there's only an a, so nothing there to combine. And for the b's, b times b, b to the first times b to the first, add those exponents, gives us b to the second. Now the next one is an example of one that, my gosh, it looks like it's going to be so much tougher. It really isn't if you keep track of things. So let's look first. The 2 and the 5, those are my coefficients. Those multiply to 10. Now let's talk about a's. A to the 0, that's just the number 1. And multiplying by 1 doesn't change anything. I don't even need to worry about that a. So let's focus on that one and that one. Negative 1 and 2, add those exponents together. That's just 1. So we end up with a to the first. There you go. And as far as my b's are concerned, here's b to the first, b to the third, b to the negative first. So add those exponents together. You end up with 3. So we end up with b to the third. See, looks a little scary. It's really not so bad. Next up, same deal. Let's see what we got. So coefficients first, 3 times 7, so that's 21. A to the second times another a to the second. Add the exponents together. 2 times 2, or 2 plus 2 rather, would be 4. And as far as b's go, well, there are no other b's, but the exponent is negative. So move the b downstairs and make it a positive 2 for the exponent. We're all good. Okay, next up. Coefficients 6 and 4. Now I do want you to reduce your fractions. So 6 and 4 are both even. Divide by 2 and divide by 2. Now, if you are like many other people in the world, you're not super comfortable with fractions maybe, please take advantage of your technology. If you're using your Desmos, just type in 6 over 4, and to turn it into a reduced fraction, hit the fraction button in front. If you're using a handheld calculator, you can do the same thing. Start off with 6 divided by 4. Let me turn this on. We'll do 6 divided by 4. And then go into your math menu and choose that very first option. It'll turn it into a reduced fraction for you. It's a great way to check your work too. So 3 over 2. Now let's take a look at m's. So for my m's, I've got, well, m to the 0 on the bottom. Anything to the 0 power is just the number 1, and multiplying by 1 doesn't change anything, so this has no impact. So my only m's are on the top. And for here, let's apply our subtraction idea. So take the top exponent minus the bottom exponent. I'm subtracting the exponents because it's a division problem. Minus a negative is like a plus. This ends up being a 5. So we've got n to the 5th up there at the top. So you may see it written this way. I don't know, the answer key might also write it this way. They're the same thing. You can use whichever of those two versions you think is prettier. One or the other. Okay, next up. On this one, okay, as we look at our coefficients, so 7 and 4, that's already in lowest terms. Now, as far as the x's are concerned, x to the third on the top and x to the third on the bottom, anytime you've got the exact same amount, that means you don't have any left, because you don't have any extras left to be on the top or on the bottom. They're just kind of gone. The y, there's no other y's, so leave it where it is. There you go. Now, this is the same thing as 7/4 times y, and so you can feel free to write it either way. Let's keep going. For this next one, 6/7, that doesn't reduce any further, so it's going to stay 6/7. Now, this is one of the first times we've seen this. I've got a negative exponent that's already on the bottom, and there's no other x's. I want that exponent to be positive. So same thing, flip it. It's going to move to the top and become a positive exponent. So if a negative exponent is already in the bottom, flip it up to the top and change it to a positive. So reciprocate works both ways. Top goes to bottom, bottom goes to top. For this one, let's take the top exponent minus the bottom exponent. Minus a negative turns to plus, so we end up with a y to the third up top. So that's good. You may also see it written as 6/7 times x cubed y cubed. And I should say we use the term squared for the second power and cubed for the third power. That comes from area and volume. Okay, let's, just a couple more here to wrap things up. Notice here, it's a power in parentheses to another power. This is the multiplication one. So for the x's, what I want is to take the exponent of 3 here times the exponent of 3 from the outside. That's going to leave us with x to the 9th. For the y's, take the exponent of 2 from the inside times the exponent of 3 from the outside. That's going to leave us with y to the 6th. Onward. Now on this one, let's go back to a pen here. On this one, it's actually the variables that are a little bit easier, because folks very often forget that you've got to take the 3 to the third power as well. 3 to the third power, that's 3 times 3, which is 9, times 3 again, which is 27. And now for your a's, take the current exponent of 2 times that exponent of 3, should end up with a to the 6th. And again, I know I'm multiplying the exponents because of the parentheses. It's power to a power. B to the second to the third, power to a power, those get multiplied. It's going to be b to the 6th as well. Okay, and then lastly here, you got a couple of different ways you can go about this one. I'm going to show you 2, I think. Here's the first. One is to say, all right, I've got 8. I've got to take that to the power of -3. Let's do that on its own. Now that number is going to get pretty big, so I'm going to pull up my calculator. I'm going to do 8 to the power of -3. All right, so that's a big old decimal. I want to turn it into a fraction. Oh, so 1/512. Ooh. So this is 1/512. Next, the n also gets raised to the power of -3. Now the current exponent on the n is a little 1. So 1 times -3 is just -3. It's up to us to remember, okay, negative exponent means it's going to go to the bottom of a fraction and become a positive exponent with that placeholder 1 on top. So for a final answer, let's put these together. So I've got on the top a 1 times a 1, and on the bottom 512, and n to the third. So that's one way to think about it. Here's another way. We're going to get the same answer. For some of us, this might make a little more sense. You can say, all right, I know that when you have a negative exponent, that's the same thing as a positive exponent reciprocated. So I'm going to think over here in red. That means that 8n to the -3rd is the same thing as 1/8n to the +3rd. Now, the only reason you might want to think of it that way is that now I don't have a negative exponent to deal with anymore. I can just do 8 to the power of 3, 8 times 8 times 8, which is 512, and n to the power of 3, which is n to the third. Look at that, you end up in the same spot. So you can choose whichever method there you prefer.